What about the inverse trig functions? Well, the first thing we need to do to understand them is to draw a graph of them. Let's start with sine. Sine looks something like this, right? So this is y, this is x, then this is sine, right? We can use this to work out what the inverse sine is, okay? So if this is y equals sine x, remember, for the inverse, it can't go between 1 and minus 1, yeah? It can't. So we know that it has to be, I want to say asymptotal, but not really, because it will touch the y-axis. It's going to look something like this. Sorry. Mouse slip there. Something like that. Whereby this, at what point is this minus 1? And this has, sorry, this is 1, this is minus 1. Yeah? What point do you think this is up here? It has to be pi over 2, doesn't it? Why? Because when this graph is at 1, is at pi over 2. And the same thing can be said over here. Here it's minus 1. So here it also has to be pi over 2. Okay? Right, now let's look at cos. A cos graph looks something like this. I'm going to have no space for tan, but we'll make it work. Yeah? And what can you tell me about that? When it's minus 1, this is pi. And when it's 1, it's 0. So, a cos graph is going to look very similar to a sine graph, where it will obviously go the other way, just because of the nature of how sine and cos work. But it's going to look something like this. Why? Because this is 1, and what happens when cos x is 1, 0, it's equal to 0. And what happens when it's 1, or minus 1, this here becomes, if I actually extend this further, this here is pi. Okay? What about tan? Well, if we look at a tan graph that looks something like this, we know that tan looks something like this. And where is it asymptotal at? Pi over 2, or 90. And then 3 over 2 pi. So a tan graph, inverse, sorry, this is inverse cos x. This will be y equals inverse tan x. Right? It's going to look something like this, whereby it's asymptotal to pi over 2. Why? Because at the points at which pi is over 2, you can't have a value for tan x. So those are the 3 graphs that you have to know. Is this making any sense? Well, make sure you subscribe so that you never miss a video from me. Now let's use this sort of understanding to answer big man questions. The first one. Given that x satisfies arcsine x equals k, state a range of possible values for k. Okay? Remember, arcsine x, right, has to be between what? It has to be between negative pi over 2 and pi over 2. Right? If this is angle alpha, let's say. Right? Can't go more than that. Think about the graphs. The graph looks something like this. This is pi over 2. And this is, negative pi over 2, positive pi over 2. And this is 1 minus 1. Minus 1, 1. Okay? So that has to be where our angle is. So in this case, though, right, we're told K is between 0 and pi over 2, right? What does that mean? That means that arcsine x is an increasing function. Which means that it's going upwards. I think I covered this in my differentiation series, which you can check out. And so because of that, and because it's going between 0 and pi over 2, that represents this value here, where the range is between x is between 0 and 1. Yeah? So now, if this is the case, express in terms of x, right, where arcsine x is equal to k, cos k and tan k. Whenever we have stuff like this, where we have to put it in terms of something else, a good idea is to think of it like this. If arcsine x is equal to k, then that means then that x is equal to sine k. Okay? It's in reverse to what we would normally do in trigonometry. That means then we can manipulate the cos equation. Cos squared k is equal to 1 minus sine squared k. So therefore cos k is equal to root 1 minus sine squared k. And what did we just say about sine k? It's equal to x, which means that cos k is equal to the square root of 1 minus x squared. Alright? We can use the same hypothesis with tan. We know that cos k is this, and guess what? Tan k is equal to sine k over cos k, right? Which means that tan k is equal to x over the square root of 1 minus x squared. If we want to rationalize that denominator, we can. Yeah? So all it is we're manipulating the equations, and then we are going to use the trig identities to work out what cos and tan are. Finally, given that instead k is between negative pi over 2 and 0, how will that affect the answers to part B? All it means is that instead of looking over here, we're now looking over here. Okay? So, what do you know about cos, right? Whenever cos is negative, so like let's say cos of negative k is equal to k, is equal to cos of k. That's just the way that the cos graph works. Why? Because cos is symmetrical. Yeah? So the value will be absolutely identical because of cos k. Yeah? That's just the way that the cos works. What about tan? Well, tan again, if we look at the graphs. Tan will look something like this. I'm sorry. Well, if you remember correctly, tan equals sine over cos. And if k doesn't remain the same, sorry, if cos remains the same, then tan has to remain the same as well, because we're dividing by cos. So all it is understanding how the graphs work, and then we can use the manipulation of the identities to explain how tan works. Is this still not making any sense? Well, you can join my Discord server and ask me whatever questions you want down below. Now let's look at this one. Prove that arc cos of x is equal to arc sine of 1 minus x squared. As I said before, whenever we have this sort of proof, we always let y equal arc cos x. By the way, arc cos x just means inverse cos x. It's just a fancier way of doing this. If this is the case, then we have to do it in reverse. Cos y is equal to x. Yeah? Alright. Now we can manipulate this as a trig identity. Cos squared y is equal to 1 minus sine squared y. So therefore, the square root of 1 minus sine squared y is equal to x. And so what we can do is we can square both sides. So 1 minus sine squared y is equal to x squared. We can add the... okay, let's add the 1, sure. So we can do minus sine inverse y, which is equal to x squared minus 1. We'll change the signs of everything. So then that becomes 1 minus x. Right? Which means that... Sorry, this is sine squared. Sine y, excuse me. So therefore... No, sine squared. I was right before. Now we can square root it. So this is sine y is equal to the root of 1 minus x squared. And so therefore y is equal to the arc sine of 1 minus x squared. And if you remember correctly, y is equal to arc cos of x. Which is exactly what we have up here. Now, why is this not the case when it's between minus 1 and 0? If you remember correctly though, let's draw the graphs. So, between minus 1 and 0, right? Cos will go from... Sorry, arc cos will go from pi over 2 to pi. This is on the first slide because of the graph. If we look at the sine graph, however, sine goes between minus pi over 2 and 0, between that case. And as you can see, because it doesn't go between negative pi over 2, okay, there is absolutely no solution for x where x is between minus 1 and 0 for this. Okay? And it's all because of the graphs right here. Thank you guys for watching. I hope this video made sense. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me today. Drop me an email to organise a meeting and a quote. Keep on learning as you have no idea what you're capable of doing.